Okay, so this unit is all about the mole. Now, the mole is not this rodent that digs in the ground. The mole is, in this case, actually a counting number that we use in chemistry. Okay, so let's take a look at this recipe. Anyone recognize this recipe? If you do any baking or even eating, you probably recognize it. And this is, last ingredient is a dead giveaway. This is a Toll House chocolate chip cookie recipe. So there are 3 different ways we measure, and you can see them all in this recipe. So think about what they are before I tell you what they are. Alright, so the first one is volume, right? So a volume example of that would be 2 1/4 cups or 1 teaspoon. That's a volume measurement, right? The other way we measure is with mass. And here we got 12 ounces. That would be a mass. What's the third way? It might not be so obvious unless you look at all the ingredients. And the third way is by counting, right? 2 large eggs, 2 sticks of butter. So the third way is counting. Okay. So here's a recipe in the form of a chemical equation. So 2 hydrogen plus oxygen gives you 2 H2Os. The chemical equation is nothing more than a recipe. 2 of those, 1 of those, give you 2 of those. What are the units for a chemical reaction? Well, we've got this 2, but what is the 2 suggesting? It's actually molecules. 2 molecules of hydrogen plus 1 molecule of oxygen gives you 2 molecules of water. So we're counting, but it's not really very practical to count 2 molecules or to count 1 molecule, since we really can't even see a molecule. It's too small. So we need to find some more practical way of measuring. And that's where the mole comes in. The whole idea of a mole is a mole allows us to count how many atoms or molecules we have by using some other way of measuring. So the mole is nothing more than a count. We talked about this in the last podcast. It's a count. Just like a dozen means 12, a gross means 144, a ream means 500. It's just that it's an absolutely enormous number. And the mole is so important in chemistry that this is National Chemistry Week. And the reason why we celebrate it this week is because October 23rd falls this week. So 10/23 is actually National Mole Day, which kicks off National Chemistry Week. And because the scientist, this Italian scientist Avogadro, not avocado, is the guy that came up with this number of particles. So we use moles to allow us to convert to something more useful that we can actually measure, like mass or volume. So why is that number so enormous? Okay, it's huge because the things we are counting are so small. The atoms and molecules are so tiny that you need an enormous number of them to have a weighable quantity. And it's all about having a weighable quantity, something I can measure in the lab. Okay, so that's why it's so huge. So just how big is a mole? Well, a mole, we can have a mole of atoms or a mole of molecules, but we can have a mole of soft drink cans. So if we had a mole of soft drink cans and we laid them side by side, we would have enough to cover the entire surface of the Earth to a depth of 200 miles. Now, is that a lot of soft drink cans or what? Okay, if you had an Avogadro's number, which is what we call the mole, right, 6.02 times 10 to the 23rd, so when we said we have an Avogadro's number of particles, let's say if we have unpopped popcorns, little tiny things, and spread them across the United States, the country would be covered in popcorn 9 miles deep. That's a lot of unpopped popcorn. Okay, and the last example I'm going to give you, if we were able to count atoms at the rate of 10 million per second, which of course you can, but if you could count 10 million per second, it would take you 2 billion years to count the atoms in 1 mole. It is an enormous number. I mean, my number's too large. My zero's too large. It's that many, right? Just mind-boggling how enormous. But I need that many to get something that I can count. So, for instance, if I took 18 milliliters of water, that's a mole. You know what a milliliter is now. We've been using it enough. It's a pretty small quantity of water, but it's got that many molecules of water. Okay. Okay, so we're going to stop there for today.